Wood's a complex material, it's a natural material. Every species has its qualities, every tree has its qualities depending on how and where it's grown. We forget that, the timber industry has inherited a 20th century thinking about building materials, like how we work with steel or concrete, which is to standardise, to try and make everything the same. Like, wood's not like that in reality. Glulam and CLT, they're amazing things which do help give us sort of standardised material. Obviously, a lot of the projects you have to standardise, but at the same time, it's really important to understand where the wood comes from, how it's grown, how it fits into the wider context of forestry and our timber industry. I'm Martin Self, one of the founders and design director of Xylotek. Xylotek we formed 5 years ago. So we're in the Xylotek workshop. This is in Bristol. It's an assembly and prototyping space. It's not a big industrial factory. It's somewhere that we can do our R&D, establish our processes, do some of the pre-assembly work.
I think we are probably part of a bit of a renaissance in timber engineering globally. People and institutions are putting a lot of money and effort and time into R&D in what you can do with timber. And what you can do is growing year on year at the moment. It's really exciting. And there's a bit of a gap between what people want to do and what people know how to do.
I'm Oscar Emanuel. I'm one of the founding directors of Xylotek.
My background is in timber construction in various different sectors. So I've worked from forestry all the way through to processing and delivering mass timber buildings. I guess I've always been interested in
Pushing boundaries of what you can do with timber.
And then with my background, I guess a bit more in academia and engineering, we brought that together, that mix. We worked together at Hook Park, the Architects Association School. So the mix of understanding of the making, a bit of a craft approach and understanding the technologies, and then how that works alongside the digital world is really key to what we do with Xylotek. The material's complex. You have to understand that by actually working with it. Working with your hands, working in an embodied way with the wood is the only way you really understand its full complexity. But at the same time, it's very hard to fully simulate it or to model it or to do that without a really strong computational skill set.
The Canada Water project is a very interesting project for Xylotek. It's a regeneration project of the Canada Water dockland. The interest for the project for us was it's quite a complex form in itself. It's doubly curved. We looked at various different strategies, and the one we fixed upon was prefabricating deck panels that could then be lifted on site. So there is a lot of computer design, and then there's also a lot of numeric machining happening in various different distributed supply places. Architecturally, there's the obvious advantage for timber. You've got the biophilic design part of timber where it enhances people's experience of the environment around them in a proven way. The molecular and engineering properties of timber do lend itself to being preformed into curved elements in quite a complex way, but in a way that can be very carefully controlled. Having a project like that that's built completely off-site and then taken to site and put together in a relatively efficient way really puts a lot of benefit in timber.
The tree is an advanced technology. The tree is an incredibly sophisticated 3D printer. You think about maybe where leading high-tech industry is trying to work with materials. Wood is already doing that. There's this evolved system that can take atmospheric carbon, turn it into cellular building blocks, build that in this sort of annual cycle, create this structural material that has built within it all of its transportation systems, adapts to its environment. It creates very sophisticated structural reinforcement. Wood's own technology, we're only just starting to make use of. So combining that with our own invention, our own thinking about what we can do with that just seems so exciting, and the potential is so huge. How you realise those complex sculptural structures in a high-tech world, actually in a weird way the pace is quite slow. It seems like we're maybe working in some sort of romantic sort of idea about working in a craft way, with a traditional material. That's not how we're thinking about it. Our ability to simulate structures, our ability to model them, our ability to I guess, bring that to the client, to the architect at an early stage.
We really want to enable things to happen where perhaps timber was never really considered, or it's considered very early and then chucked aside. We want to come in there and enable those things to happen, and by doing that we make an impact in the built environment.
It's so evident that timber is so key to the future of how we're going to construct our built environment. It's a really key thing for humanity's future.
And we think bringing more timber into the built environment on a global level is only for the benefit of the planet. And so, yeah, we want to make a positive difference, really.